Good afternoon. In this video, we will be talking about slope. Slope is defined as the rate of change of y with respect to x. In other words, if I move 1 in the x direction, right? If you change your x by 1, how much does your y change? Is the rate of change. Okay? So slope actually has a lot of different applications. Anytime that there's a rate or a proportion, it could be related to a slope. For example, very common example is speed. Let's say you're going on the highway at, I don't know, 10 miles per hour. Okay, that's a speed right there. It's 10 miles for every 1 hour traveled. So that's to say, if I increase my time by 1, if I spend 1 more hour in the car, I will have gone another 10 miles. All right, so slope can also be quantified. This is really where it becomes the most important. Slope is defined as the change in y over the change in x. Change in x. That change in right there is often just replaced with the symbol delta. So delta y over delta x, and that's equal to your slope. M clearly stands for slope, because what else, right? Okay, so slope, in order to get the slope, right, all we need are 2 points. On any grid, on any xy coordinate plane, here's your x-axis and there's your y-axis, all we need are 2 points to get the slope. Let's go, I don't know, 1 and 2. Okay, so the slope is going to be defined as your change in y, right? That's how much up we're going. So this distance right here, we'll just call it the change in y over change in x. That distance right there, change in x. Okay, and that'll be the slope of the line connecting them. All right, so let's just do some practice examples. So if we have the points, let's say 3, 4, and 5, 8. All right, so here are 2 points. One thing that you have to watch out for with slope is that negatives matter. If you have a positive or a negative slope, it will mean different things. So you have to be extra cautious as to say, okay, am I changing up or am I changing down? Is my change positive or is my change negative? All right, so let's start with the x's. We're going from 3 to 5. So since we're increasing, I'm going to say that that change is positive. We're going up 2, right? That changes 2. So our change in x is going to be 2. Okay, how about y? We're going from 4 to 8. Again, we're increasing. So our change in y is going to be 4. So put it all together, we'll get our slope is change in y over change in x is just going to be 4 over 2, and that is 2. So here our slope is 2. Let's do another one. Let's go from 12, 10 to, I don't know, 22. All right, here's what we have. Same as before, we're going to start with the x's or y's, doesn't really matter. Change in x is going to be from 12 to 20. That's an increase of 8, so it's going to be positive 8. Change in y, we went from 10 to 2. Now we're decreasing. So our change in y was actually negative 8 because we're going down. Put it all together, we'll get our slope is your change in y over change in x. Slope is going to be negative 8 over 8, which is just negative 1. Okay, so now that we've showed some examples of what slope is, how to calculate it, let's look at what it is graphically or visually. All right, so if we have our just normal coordinate grid, let's say we have 2 points. Let's go, well, let's do the first example. We'll go from 3, 4 to 5, 8. So it's about 1, 2, 3, from about here to, I don't know, whatever, right there. So here are my 2 points, 3, 4 to 5, 8. As you can see, if I were to connect a line, it appears to be going up. There's an upward trend in my graph. Makes sense because my slope over here, as we calculated earlier, was 2. So since my slope was 2, that's a positive value. My line is going up. Everything checks out. Let's try the other one. We go from, well, let's put it over here. The other one, we had a point like up here, and then another one down here. All right, and our slope was negative 1. Here, you can see that we're actually decreasing. Our slope is negative, and the line is decreasing. So it makes sense. It's consistent with what we want. Okay, so these are the 2 main cases of when slope is going to be used. It's going to be either positive or negative. But there are other types of lines. There are some special cases when it comes to slope. We're going to start off with a horizontal line. Okay, so here's my x and y axes, I don't really know. And let's say here's my line. Okay, and I'll actually tell you 2 points. I'll tell you that this one is going to be -2, 10, and this one is going to be 5, 10. Okay, those are my 2 points. You'll notice that this line is actually perfectly horizontal. It's not increasing and it's not decreasing. It's kind of just staying flat. Well, let's calculate the slope. Change in y, we went from 10 to 10. Okay, so you can put that in the calculator, or you can just recognize that that change is 0. The change in x was from -2 to 5. That's an increase of 7. So if we put it all together, slope is change in y over change in x, and that's going to just be 0 over 7. As we know, 0 divided by anything is going to be 0. So here we've demonstrated that a horizontal line has a 0 slope. Okay, now let's try a vertical line. Again, we have our x and y axes, and let's just put the line right here. Okay, as we said before, you need to have 2 points in order to define the slope, so I'll just come up with them now. Let's call this 4, 6, and this will be 4, 1. I missed a little bit. All right, 4, 6, and 4, 1. All right, change in y is going to be an increase of 5, and the change in x, well, we started at 4, and we ended at 4, so the change in x is just 0. All right, let's put it all together. Okay, change in y is 5 over change in x is 0. Whoa, hold up. 5 divided by 0? We can't do that. Any number divided by 0 will result in something undefined. It doesn't work. So here, a vertical line has an undefined slope. We can't actually put a number on it. Okay, so those are the examples of slope, horizontal, vertical lines, and just normal positive and negative slopes. Okay, thank you for watching, and I'll see you in the next one.